Hey you guys, I don't know how many days of isolation it's been, but math class is still kicking on. Over here, you can see the problems that we're going to be working with today. Make sure you hit that subscribe button and ring the bell for new videos every week. Okay, let's go.
In this first example, we are being asked to factor this expression here. Our first step requires us to take out a greatest common factor. So what that means is we need to identify the greatest expression that will go into each one of these terms. I like to focus on the numbers first. We've got 9 and 24. The greatest number that can go into each of those is 3. Now for the letters. We have an x cubed and an x to the power of 5. To find the greatest common factor of these two, we just take the one with the smallest power, so in this case, x cubed. Focusing now on the y, we've got y to the power of 4 and y squared. Again, we take the one with the lowest power, so y squared in this case. We've now found the greatest common factor, so what we're going to do is open up a set of parentheses. The next thing to do is ask ourselves, 3x cubed y squared multiplied by what will give me this first term here? Well, 3 times 3 will give me this 9. I don't need to add any x's on as I already have an x cubed out the front of my parentheses. For the y, however, I need y to the power of 4. I have y squared out the front of my parentheses, so I need to multiply it by another y squared. So when we multiply it back out, we get that y to the power of 4. On to the second term. So now we're asking ourselves, 3x cubed y squared multiplied by what will give me the second term of positive 24x to the 5 y squared. Beginning with the numbers, 3 times positive 8 will give me the positive 24 we're after. I need x to the power of 5. I've only got x cubed out the front, so we need to multiply now by another x squared, as the x cubed multiplied by the x squared will give me the x to the power of 5. Finally, for the y, I need a y squared. Out the front, we already have our y squared, so I don't need to add any more y's in here, which tells us that we've completed our factoring. Let me tidy it up for you. And we're done. On to example number 2. In this example, we are asked to factor this expression here. To factor this expression, we need to find two numbers that multiply together to give us positive 16 and add together to give us negative 10. Let me set up a couple of tables that we can work with. Starting over here, we need to come up with the factors of positive 16. I'm going to start with 4 times 4, as that gives positive 16, as does negative 4 times negative 4. We have 2 times 8 gives us 16, as does negative 2 times negative 8. We've also got 1 times 16 and negative 1 times negative 16. Now that we've written down our factors, we're going to go across here and find out which pair actually add to give us negative 10. We can start with the 4 plus 4. They add together to give us 8. Negative 4 plus negative 4. Well, the positive and the negative give us a negative, and negative 4 minus 4 is negative 8. 2 plus 8 gives us 10. Negative 2 plus negative 8. The positive and the negative give us a negative, and negative 2 minus 8 gives us the negative 10 we're after. Hooray! So we can see that negative 2 and negative 8 are our factors. This means that we can rewrite our expression in factored form as p minus 2 and p minus 8. As p is the pronumeral being used in our expression, and negative 2 and negative 8 are our factors that we're using. Example 2 complete. Let's move on to number 3. In example 3, we are asked to factor this expression here. You'll notice that the coefficient of the m squared is actually larger than 1. Don't fear, I know that it can look pretty confusing, but trust me, I'm going to make this as simple as possible. I'm going to start by rewriting our expression. Now we're going to pick up this 4 and multiply it by our constant of 9. So we'll have m squared as I'm picking up this 4 and multiplying it by the 9 over here. Then I've got minus 13m that I've just dropped down, and then I'm going to multiply 4 times positive 9 gives me positive 36. Now we just factor this expression like we did in the last example. We need to find two numbers that multiply together to give us positive 36 and add together to give us negative 13. So let me set up a couple of tables. Let's begin with our first table here. We need to come up with two numbers that multiply together to give us positive 36. Let's begin with 4 and 9. 4 times 9 is 36, as is negative 4 times negative 9. 2 and 18 also multiply to give us negative 36, as does negative 2 and negative 18. I'm going to finish writing out my factors now because I'm pretty sure that one of these sets is going to add to give me negative 13. 4 plus 9 gives me positive 13. Negative 4 plus negative 9. Well, the positive and the negative cancel out to give me a negative, and negative 4 minus 9 is negative 13. This tells us that negative 4 and negative 9 are our factors. So I'm going to bring that back over here and rewrite this expression in factored form. So we have m minus 4 multiplied by m minus 9, which comes from here. Now we can't forget this multiplication of 4 from earlier. We need to go back now and undo that operation. So what I'm going to do is divide each of the constants inside the sets of parentheses by that 4 that we multiplied out in step 1. Now I'm going to simplify as much as possible. M minus 4 on 4 is just 1. And m minus 9 on 4, I can't break down any further, so I'm just going to rewrite that as is. It's not really conventional to leave a fraction inside a set of parentheses like this. So what we're going to do is pick up this 4 and multiply it by the m inside that same set of parentheses. So I've just dropped that down. Multiply it by 4m minus 9. So I just picked up that 4 and multiplied it by the m to give us the 4m. Another problem complete. Let's go on to our final example, number 4. In this problem, we are asked to factor 36g squared minus 25. We're going to use a special rule in this example called difference of two squares. So what we're going to do is rewrite this expression using squares where possible. I'll start by rewriting our expression. 36 is the same as 6 squared. So we've got 6 squared times g squared minus 25 can be written as 5 squared. I'm going to tidy this up so it looks a little nicer. So we've got 6g all to the power of 2, as the 6 is getting squared, as is the g, minus 5 squared. Hopefully you can recall our difference of two squares rule. It states that if we've got one squared value being subtracted from another squared value, we can rewrite it as this. This 6g is acting as my x variable, and this 5 is acting as my y variable. So now what we can do is wherever we see an x in our formula, we'll replace it with 6g, and wherever we see a y in our formula, we will replace it with a 5. So we'll be left with 6g plus 5 and 6g minus 5. And that's it, our final problem complete.
Thank you so much for watching, and as always, if pre-calculus is what you're studying, you can visit the link in the description section below and study with me. I'll see you in there. Bye.